To create our own AI image classifier, we're going to use Microsoft's Custom Vision service at customvision.ai. In order to log in to the Custom Vision site, you need to already have a Microsoft Azure account. Logging in to the customvision.ai site with your Azure account details means you can create all of the resources you need in one place. If you don't already have an Azure account, students are able to get $100 free credit if they sign up for an account via aka.ms/Azure for Students. There are more details about this if you need them on the help pages at the aigaming.com site. At Microsoft's customvision.ai site, make sure you've signed in with your Microsoft Azure account details. You'll be presented with the option to create a new project. Choose this and we'll set up our Planet Recognition project. Name your project. Let's call it Planets. Now we can create a new Azure resource for this project. Click the Create New button and a new dialog box will appear. Name your Azure resource AI Challenges. Select your free trial subscription. Create a new resource group to help organize your Azure resources by clicking the Create New button and naming your resource group AI Gaming. Select West Europe as the location. Choosing West Europe is very important. The AI Gaming servers are located in West Europe, so your code will perform the quickest if it is also located in West Europe. Choosing any other location will restrict how well your code can perform on the AI Gaming platform. Leave the kind of resource as cognitive services, which will create both a training and prediction resource for us. Set the location to West Europe like we did for the resource group. Select S0 for the pricing tier. The S0 tier uses the credit from your free trial. You need this speed of access in order to compete with other people when playing competitively on the AI Gaming site. Click the Create Resource button to create your resource. Now we can set the project options. Set the project types to classification, as we are going to categorize whole images in this project rather than individual objects in images. For the same reason, set classification types to multi-class, since our pictures will contain only one subject. And finally, leave the domain set to general. Click the Create Project button and you'll be taken to the project workspace. From here, we can complete the 2 tasks needed to create our own computer vision service that will identify the planets in our solar system. First, we'll add training images of different planets and label them with the planets' names. Second, we'll let our model train itself using the images and labels we've added. Let's get some planet images to use for training. We've created an initial set of images for you. Download these images to use now. Click the Add Images button and find the folder of images you downloaded. There are 2 folders, one folder of training images and one folder of test images. We'll use the images in the Training Images folder to train the model. Let's start with Jupiter. Open the Training Images Jupiter folder. Select all of the images in the folder and open them. In the My Tags field, enter the tag Jupiter to label these images as pictures of Jupiter. Click the Upload button to upload them and then the Done button. You'll see the uploaded images on your project workspace page. Repeat this process for the other images that you downloaded. You'll have images for Mercury, Pluto and Venus. Tag the planet images with the correct names when you upload them. Now that all of the images are uploaded and tagged, we can let the model train itself to recognize the contents of the images. Click the Train button and choose the Quick Training option. Start the training process by clicking the Train button. Training should not take very long, and when it's complete, it'll take you to the performance page and show you the results for this new training iteration. Now we can quickly test the results of this training. Click the Quick Test button and use the Browse Local Files option. Find the Testing Data folder and choose an image of Jupiter. The quick test results will show you the probability that this image is Jupiter. Try this again and use the Browse Local Files button to upload an image of Mercury from the Testing Data folder. Review the prediction results again to see how well the model has identified the image. Finally, make one more test and upload an image of Earth from the Testing Data folder. Which planet does the model think that this is, and how high is the probability? You now have a very simple model that will do a reasonable job of recognizing Jupiter, Mercury, Venus, and Pluto. If you want to improve the accuracy of your model, you can add more images for each planet and then train the model again. You can keep coming back and doing this if you see the results that you get in your code are not accurate enough, or if one particular planet performs worse than others. This is how you train and improve your custom vision model. In the next video, I'll show you how you can connect to your custom vision model so that you can analyze planet images from your Python code. Thanks for watching this video. There are more in this series, so please make sure to check them out.